Every year, thousands of workers suffer hand injuries, and many of them are cuts or lacerations. That's why choosing the right cut-resistant glove matters immensely. But how do you know whether the protection you're using is actually up to the task? Cuts, lacerations, and punctures account for nearly 44% of all reported hand injuries, according to U.S. labor statistics. That means almost half of hand injuries could be mitigated with proper personal protective equipment, if you choose it wisely. Cut resistance is a measure of how well a glove material resists being cut through. But to make that measurement meaningful, we rely on consensus standards, testing protocols that let us compare glove performance. There are two main standards in use: the American ANSI ISEA 105 standard and the European EN 388, or CE standard. The most significant changes come from the ANSI ISEA 105-2024 standard. This includes updated test methods and a new way of classifying cut resistance. Instead of the old 1 to 5 scale, ANSI now uses a 9-level scale, labeled A1 through A9. Testing is done using a tomo dynamometer machine, the TDM 100, which methodically applies a razor blade under increasing weights. The test is repeated, and the average weight needed to cut through is recorded. The measured cut resistance values now range from about 200 grams at level A1 up to 6,000 grams at level A9. If tested under the ANSI ISEA 105 standard, cut-resistant gloves will be marked with this score, listed from levels A1 to A9. Not all manufacturers label this, but many do. The updated standard also introduces a pentagon-shaped pictogram, which includes not just cut resistance, but also abrasion and puncture resistance, all in one standardized badge. This makes it much easier to compare gloves across different brands. You know exactly what protection you're dealing with. Now, what about the European EN 388 standard? EN 388 uses two main tests, the coupe test and a version of the TDM test. In the coupe test, a circular blade is moved under a constant 500-gram weight, and cut-through is measured by the ratio of rotations. That yields a 1 to 5 score. But for high-cut materials, EN 388 also requires the ISO 13997 test, which uses the TDM 100 method. The force needed to cut is measured in newtons and rated on a scale from A to F. However, EN 388's scale doesn't go as high. It stops short where ANSI's A7 to A9 lives, so ANSI's system better differentiates high-cut materials. These changes matter because they make glove selection simpler and more precise. And because the cut scale now goes up to A9, you can better match gloves to real-world hazards. You don't need to overprotect just to be safe. You can get exactly the level you need. Still, a key reminder: no glove is cut-proof. The goal is risk mitigation, not invincibility. HexArmor has long been a leader in cut-resistant PPE, using advanced materials like superfabric and a wide array of advanced knit technologies, which offer excellent protection without sacrificing dexterity. We support the ANSI ISEA standard, making it easier for you to choose the right glove for your application. If you're not sure which glove level is right for your team, our solution specialists are ready to help. They can guide you through cut, abrasion, and puncture ratings to find the right balance of protection and performance. Choosing the right cut-resistant glove doesn't have to be complicated. With the updated ANSI ISEA standard and HexArmor's high-performance solutions, you can stay safe and protect your team more confidently. Visit HexArmor.com or call 1-877-MY-ARMOR to learn more, request a trial, or get help picking the right glove for your needs. Because when it comes to hand safety, smarter protection means fewer injuries, and that's something everyone can feel good about.